posterity. And all right, welcome to the April, whatever month this is, year, user group. We have today Russell Uman talking to us about how Splunk runs Splunk Cloud. And we're very happy to have him on relatively short notice that the talk existing wasn't the case a few weeks ago. So thank you for pulling it together and bugging enough people to make it happen. Take it away.
All right, hi, give me a second to figure out which screen I'm sharing. Dun, 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 dun. All right, now, question is, can I share this screen? Oh, this is amazing. All right.
We can see.
Fabulous. All right, so Eugene, actually, I guess someone in the user group wanted a talk on how Splunk at Splunk manages Splunk, and someone pointed him at me. And I don't know about that. I know about how Splunk Cloud manages Splunk. So that's what I heard him ask. And I said, sure, of course I can do that. And then it took us about a week to figure out the miscommunication, at which point it was too late for Splunk at Splunk to put a presentation together. So you have me. I think you'll get Splunk at Splunk in a future user group, and
Yes.
that should also be really interesting. And that will be closer to sort of advice you can use for a Splunk that you run. And they've also released and open sourced a lot of their tools. So do turn in for that. But in the meantime, you have how Splunk Cloud manages Splunk. So legal has advised me that I have to read this whole slide before I can continue. This presentation may contain, okay, I'm kidding. TLDR, everything I say to you today might be a lie or what we call a forward-looking statement, but I will do my best not to lead you astray. I've been at Splunk since 2012. I was originally the engineering lead for the docs.splunk.com website, and then I moved to Splunk Cloud and took an SRE role with a focus on monitoring. And I ran the big Splunk that Splunks all the Splunks for Splunk, the Splunk Splunking Splunk. And now I'm on the Cloud Business Enablement team as a data scientist using Splunk to analyze the AWS and GCP billing reports and correlate them with product behavior so that we can blame things for why we're spending so much money and then stop spending that money, which I think objectively is really boring, but I love it. It's really enjoyable. So here's what we're going to talk about. They always tell you to, in your presentation, tell them what you're going to tell them, and then tell them what you told them. I don't do the last part. I'm not going to tell you what I told you afterwards, but here's what I'm going to tell you. This is mostly a high-level talk. I'm fairly ignorant about the depths of these topics, especially the middle two. But if you ask me questions that I don't know how to answer, I will definitely follow up in the user group Slack today or tomorrow. What is inside your Splunk Cloud stack? It's fairly similar to what's in your on-prem stack. There's a bunch of dedicated instances. You probably have a management node, but you might not. That's a forward-looking statement. My Splunk stack no longer has a management node. It's very exciting. You might have an inputs data manager, which is it's like a heavy forwarder, but it only runs mod inputs and scripted inputs. You have some indexers and you have some search heads. You've got some EBS volumes. This is AWS specific, but the GCP side is all analogous. And an S3 bucket for Smart Store. Internally, we call Smart Store S2, so it's an S2, S3 bucket, which gets really confusing. You got an ELB for HEC, you've got a VPC and security groups and sort of all the other stuff, right? And we have to manage that for a couple thousand customers. So we need systems to provision and manage that stuff. Current state, at the resource level, everything's managed by Terraform. We use Jenkins to kick off Terraform jobs. Instance configuration and Splunk configuration is managed by Puppet. The configuration, there's sort of 4 Git repos. There's like a shared Terraform, stack Terraform, shared Puppet, stack Puppet, all in Git. And then we have a bunch of services that link up the configuration in those repositories with the actual running instances and stacks. And actually, I want to go further back in time than Rainmaker here. Does anybody in this room remember Splunk Storm, except for Splunkers? Splunk Storm was our first attempt at a cloud Splunk, and it was multi-tenant Splunk, but we just used Splunk to do it. So you would basically have multiple customers using the same Splunk instance, and we rewrote a lot of the user interface so that people wouldn't step on each other's toes. Like if you created an index, it would be namespaced. It did not work very well. It worked about as well as you would think. Having multiple completely separate customers on the same Splunk works. It's sort of a hard way to do it, and eventually we closed that experiment. Their mascot was the narwhal because Twitter had the fail whale. So we had it was like a win. It was Narwin, the narwhal. And we actually put him in a coffin and carried him around the office in a wake. But shortly thereafter, Godfrey, the CEO at the time, learned that Sumo Logic let you click a button on their website and get a trial instance. And this really, I guess, enraged and excited him. And he told us that we had 6 weeks to do the same thing for Splunk. And so we built this system called Rainmaker. The project was called Hair on Fire. And we took all the Storm alums and they built a set of microservices because microservices were cool. And we used Chef. And it was actually surprisingly robust. There are still customers on single instance Rainmaker. And we only retired Rainmaker for trials sort of middle of last year. The model was basically you had a pool of running instances that were unallocated. And when you push the button on the website, one of those instances would get assigned to you, and some gears would turn in the background to set up account and SSO login stuff, and you'd be off to the races. And so then subsequently customers came to us and said, well, we want more than a single instance. We want you to Splunk host our entire complex clustered Splunk. And we said, okay. And so the extension of Rainmaker was called StackMaker. And we used Terraform and Jenkins and Ansible instead of Chef. I have no idea why. We had we built this front end on top of Jenkins that would let you manage the Terraform configurations, which were in Git, but you would manage them through this web UI. So you'd sort of like, get in there and click a few buttons to add indexers and then fire off the Jenkins job and it would run the Terraform. The biggest downside of this system was that there wasn't really a configuration inversion control on the Ansible side. The state of the stack was kind of the sum total of all of the Ansible and customer actions that had been taken on the stack. We backed up the Splunk Etsy directory. There were snapshots, you could restore it, but it was very hard to reason about all of the stacks as a whole. And that made upgrades really complicated. There were just sort of lots of weird failure corners. It was definitely more pets than cattle. And so we replaced that with a system called Cloudworks. And this could be its own sort of mini series because the Rainmaker folks wanted to build clustered Rainmaker to replace StackMaker. But the SRE folks wanted to build Cloudworks, and it was a big ops versus dev battle that sort of raged over a year and a half and multiple full products reorgs. But eventually Cloudworks got built. We also took that opportunity to migrate people to Smart Store away from Dumb Store. Puppet replaced Ansible. Puppet configurations for both shared fleet-wide configuration of both instances in Splunk and individual Splunk situations configurations went into version control repositories, which was great. And that UI on top of Jenkins went away. Jenkins became kind of a dumb tool. And so the way you would operate Splunk with Cloudworks is you would make a merge request to a repository, and then you would either run Jenkins through the Terraform or just sort of sit back and wait for Puppet to do its thing. And it was a lot better. It's been a lot better since Cloudworks. It's been sort of, things feel like they are predictable and reliable and can be replicated, but we wanted more. And so we built CO2. I think it was launched early last year. And CO2 is a service layer on top of Cloudworks. And the way it functions is it sort of, for a given stack, it'll pull all 4 of those configuration sets, the global Terraform, the stack Terraform, the global Puppet, the stack Puppet, into a single artifact, which gets published to S3. And then it will apply that bundle out to the stack. And it's got a web interface and a CLI interface, and they both talk to the same API, and that API is robust and we can automate against it. And so, I don't know, if you love version control systems like I maybe do too much, it's slightly annoying to have to do stuff through a web UI, but the start to finish of doing something like a support assisted app install, it's a lot faster. And so now we can talk about stack upgrades. Going through the sort of same historical process, when you wanted to upgrade the Splunk version in StackMaker, it was an operator sat down and had a run book with maybe 15 Ansible commands, and you would run them. And at some point, the Ansible wouldn't work because you had made assumptions about that stack that weren't true, because you just didn't know how everything worked, and then you would have to go in and fix it. It worked, but it was very time consuming. And Splunk Cloud in that era lagged many versions behind on-prem Splunk. We were like, it was very cloud last, and Cloudworks fixed that a lot. Upgrades are still manual, but they're not fraught. So you can have folks with a lower level of Splunk knowledge with a much simpler run book going through those upgrades a lot faster. And so we sort of caught up on the versioning, but we wanted to fully automate releases, and with CO2 we can do that. We built this system called Release Train, and it uses CO2 to fully automate the upgrade process. Stacks get binned into groups based on their maintenance window. Maintenance window is typically midnight to 2 a.m. local time, so they sort of get binned by region into like small groups. It's like 10 stacks per station, I guess, on the Release Train railway. And there's a set of stacks that are the canary stacks that go first. And if there's any errors, pages go out automatically. And if there's too many errors in a particular group, the release train stops entirely. The robot pulls the emergency brake, the train shudders to a halt, and falls off the track and explodes, and the helicopters come in with the fire suppression, and then we figure out what went wrong before we send another train down to roll over the bones of its comrade. I mean, we have this awesome patch with the skull. It's like a leprechaun skull with cards. Everyone really enjoys the extended railway metaphor. And so now when you see these versions of Splunk Cloud where it's like 8.1.2103, I think that's the latest, that's the third release of 2021, that's a release train. And we sort of do those every 6 weeks, and they mostly go off without a hitch. And that's how we do it now. So then I'll talk really briefly about the monitoring piece. This is kind of our future state for monitoring. We have Skynet, which is the big Splunk that Splunks the Splunk. I've interviewed a lot of people, and I've learned that every large organization is guaranteed to have one project that they've called Skynet. I call it the Cyberdyne principle. But so this is how monitoring works on GCP. That torch is Prometheus, which is a metric system, and then we have Signal Effects, which is another metric system. It used to be just Prometheus and then Signal Effects. Signal Effects will eventually eat Prometheus, and we'll just have Signal Effects in there. And they both send alerts to an ITSI. That's the NOC, Cloud NOC ITSI. And if ITSI decides that the alerts are like really annoying, it'll send a page to that says Victor Ops, but it should say Splunk on call. The current state in AWS, Prometheus should be replaced by Nagios, and Signal Effects goes away. And we have Thruck. I think we do still have the NOC ITSI in line with Nagios now. But Thruck is the UI for Nagios. We use the OMD distribution. That'll probably go away at some point this year, and will be full Prometheus Signal Effects, and then we'll further dog food by replacing Signal Effects. And that's it. That's my brief high-level overview of what we're doing right now, and many uninteresting years ago in Splunk Cloud. Please ask me questions.
Awesome. Anybody feel free to unmute and jump in with questions? Or we'll have a short meeting, which I guess sometimes not a terrible thing.
I have a question for you, Russ. Could you talk about how quickly we can push changes out to stacks? Like if a customer has, change scheduled, like how's that working today compared to yesterday?
So I briefly mentioned the fact that master nodes are going away. And so let me digress into there a little bit. We have an initiative to replace the cluster management node with a service, sort of a multi-tenant bucket management service. It doesn't have a public name yet, so I'm not going to name it. But the cluster master, right, is also the deployer to the indexers. And a lot of the friction right now, I think, in configuration management in cloud is around app deployment. So there are cloud vetted Splunk-based apps that you can just self-service. There are private apps that you can install yourself over self-service. But once you get past self-service, you have to go through support and have an assisted app install. And that's a really long process. And it's outside of it's not because the configuration management stuff that we have is slow. It's because the human processes around the app vetting is slow. So part of this move to a new bucket management system will also get rid of that manual vetting step. So when you ask how long a change is going to take, it depends on the change, right? We are trying very hard to make it so that customers can do everything themselves. And app install is a real focus of that. Once the app is vetted and has been uploaded to the right place in S3 where it can be deployed, it's maybe 10 minutes of work to do the tweaks. And I'm trying to think of other things. If you're expanding a stack, it depends on what we're expanding. Adding a search head or a search head cluster member should be pretty painless, or an IDM. Adding an indexer. So right now with the existing cluster manager node system, that involves a rolling restart. So for a medium-sized stack, it can take a long time just for things to settle down. That situation also gets improved a lot more with the new bucket management system. I didn't really answer your question. I mean, what kind, can you give me a specific change that you're thinking of?
Sure. So let's say that there's a maintenance release.
Okay.
What would the general expectations be around that? Nothing specific, just in general.
I think so the normal maintenance window is 2 hours. Just looking at this slide the other day, I think that the window for Splunk upgrades is still extended to 4 hours. So you should expect that you're going to get a communication from Splunk that's going to say, hey, we're upgrading your stack from here to there. And it's going to happen in this maintenance window, and there's going to be an extra 2 hours. The actual downtime is much smaller than that. We just sort of don't know when the train is going to roll through for that upgrade. And it will usually cause an indexer cluster rolling restart, which means you'll have fix-ups for some amount of time. So search will be sort of logy. So like at most 4 hours, probably closer to half an hour. And if the maintenance window ever gets exceeded, that's one of the things that makes the train blow itself up.
Cool.
Whereas I feel like in the past, like with StackMaker, it would be we would schedule a specific maintenance window outside of your normal schedule, and we would tell you it would be 2 hours, but then often it would sort of drag out into 8 or something like that. Yeah, again, once we sort of improve the situation around rolling restarts for upgrades and configuration changes, it should be much less. That's a forward-looking statement. Yeah.
Great. Anybody else have questions about that or cloud
Hey, Brandon.
questions? I think you're in a good position to be able to answer some cloud questions.
Good afternoon, Russell. This is Shadi from State Street. I have a question that is not Splunk Cloud specific. We have an on-prem implementation of Splunk, but looking at your presentation on how we are managing Splunk Cloud, we want to adopt some of those techniques for our on-prem implementation. Will you be able to share that presentation deck with us?
I can share the deck, yeah. I will post, Eugene, would it be okay if I posted a PDF in the Slack channel? And then you could distribute that elsewhere?
Yes, because the wrap up, when I send out the link, yeah, you can do that, and then I will also put in the wrap up
Great.
email that goes out after.
Great, definitely check out the Splunk Terraform provider. You can do a lot of Splunk, even beyond sort of what we're doing with Terraform. You can do a lot of Splunk configuration management with that.
Thank you.
Yeah, if you don't mind, I'd just like to add in a little bit. That's recently, over, let's say, last 6 months, 9 months, maybe even a year, Splunk as a company has truly become cloud first. So all of the product development that happens. It used to happen in the core product first that would be, used for BYOL customers. It's now going into Splunk Cloud first. And so we're going to have it there first. It's going to be burned in for about a year before we make it available for general release. So that paradigm's has shifted, right? The same is true with like enterprise security and ITSI and all the premium apps. They will all work in Splunk Cloud when there's an upgrade first, before the on-prem stuff. So just keep that in mind. Some of the things that we're going to be doing in Splunk Cloud, you might not be able to replicate right away. Hopefully, eventually you would be able to do that though. When it's appropriate for us to share, we would. Like historically in the past, like Smart Store, right? We were running that in Splunk Cloud for quite some time before making it fully available for our customers that are running on their own.
Yeah, some of the new things we're doing, I don't think we'll ever have an on-prem analog, and it's not feature things. It's really backend stuff where there's backend stuff we might build, like the new bucket management system to run our own cloud that will never get released. I do think we'll probably retain feature parity though. That's another forward-looking statement.
Any other questions for Russ or anybody else?
Can you hear me?
Yes.
For the trains, are there different trains for FedRAMP customers, or how does that occur?
Yes, FedRAMP always comes second because we want to be a lot more careful with that environment. And I don't actually know for sure off the top of my head if we're running release train in FedRAMP yet or not. I can check and follow up. But then there are often secondary concerns with Splunk releases for FedRAMP. They need extra vetting, make sure that we've maintained the compliance that we promised there. So yes, it is I think low confidence think we are using release train to do upgrades in FedRAMP, but it's definitely not part of the same standard account process. It goes through its own set of extra vetting and compliance checking, and I imagine that we have smaller groups as well, just to make sure that things don't fall over.
All right. Are there any other cloud questions or any general, like we used to sit and discuss in a room with somebody had a problem and everybody chimed in. That's not necessarily for us or anybody else. I actually have one to throw out there if nobody else does.
I have one. I can go after you.
No, go ahead. I won't forget mine.
Okay. So we have a Splunk Cloud instance we kind of inherited. And the enterprise security search head, I've seen it, I'm on it a lot. And about once every other day or so, I will get, the page will reload and I'll get a maintenance page. But it'll only stay there for a few seconds, less than a minute. So we were curious what's going on, because that's definitely a Splunk Cloud end issue.
Giving Jim a second to preempt me. It's likely, this is a guess, it's likely that Puppet has decided that the search head has restarted. I don't know why that would be the case, but it is something that sometimes happens. Some of the work we've been doing for Cloud over the past few releases, previously before Cloud, we were very sort of cavalier about restarting things. It's sort of like we didn't really work very hard to figure out what required a restart. We just sort of restarted whatever something might need a restart. And when we learned in Cloud how disruptive that was, we started taking a much closer look at what actions really require a restart, which don't, and we've been paring it down and paring it down. But there are still situations where some configuration change will happen and will trigger a restart. I think the goal is that this should never happen unexpectedly, but it definitely still does. So you should open a support ticket. You can say, why I saw a restart happen at this time, why? And hopefully they can sort of dig into it and figure out what specific Puppet thing caused the restart, and open a bug if necessary, or explain the comms gap if necessary.
Awesome. Yeah, I was just pretty new to Splunk Cloud, and I keep noticing that. I'm like, this isn't right.
Yeah.
Have others seen something like that just on this call?
I've seen that personally. So yeah.
Okay. So that's a yes then. Okay. My question was just an observation that I made, and I'm trying to figure out if I'm misinterpreting things or is it as bad as I think it is. Which is, or we're doing something wrong. But then again, our Splunk instance is more than a decade old, so it could be. If when apps usually install, they run as nobody because you don't know what the user is going to be that's going to be running, right? But running as nobody, like scheduled searches and whatnot, is effectively running them as system account, an admin, or more than admin. But also, and maybe that's something that we were doing a long time ago, or maybe that's something that is defaults to it, the power user gets write access to those safe searches. Is that normal?
Yeah. So the knowledge object will be owned as nobody if you don't specifically call out an owner in default.meta. And I do think it's normal. So whether or not the power user can write to the knowledge object depends on the permissions for the app that the knowledge object is in. And I don't know off the top of my head if the default state for a new app you create gives power write access. But again, if you in default.meta for the app or through the UI, if you edit permissions, you can control on the app level who can write to the app by default, and then each knowledge object also in default.meta or in the permissions UI, you can determine, you can set who can write to it. So you can write to a knowledge object if you can write to the app and you can write to the KO. If the KO has no specific permissions called out, it's going to inherit the permissions from the app.
Which that part makes sense, and that's what I basically did. I was wondering if others have run into this or have that in their environment and don't realize, because that means the effect of that is anybody in the power role can effectively be admin by changing what the safe search contents are and calling out to a REST service to give themselves, whatever they want. Right? Like that's really what writing to a knowledge object does, is you can change it to whatever the heck you want, and there you are.
Yes, I wonder if there's a role escalation attack through rewriting a nobody search to make a REST call. That's a really good question.
Yeah,
I'm gonna play with that.
That's what I realized. I'm like, I can't be the first one to realize that.
Mm-hmm.
Maybe I should have saved it for something else.
You shouldn't have told, because now we're gonna fix it. No, I'll look into it. That's really interesting.
It is.
Question.
Yeah, it is an issue. I at this point have a search running every week to see if one of the admins, basically, if an admin, if a search or knowledge object owned by an admin or nobody has write access from somebody other than an admin,
Mm-hmm.
right? Because that's bad. I don't think the users are savvy enough to exploit that, but I think that's an actual issue.
Yeah, I'm not sure what the default is for a new app. I'll look at that and follow up. And I'll follow up on the idea of doing something evil in REST by being able to edit a search owned by nobody. Great idea.
Yeah, we tested it out, and I owned the search. I had a search that owned by admin, and somebody was able to edit, and even if it wasn't scheduled, just able to change it to scheduled, which was strange, but there it is.
But you haven't actually done a role escalation yet through there where someone was able to give themselves admin or SE admin, have you?
I haven't tried to do that part, but that would leave more of a trail than if you just run whatever you want.
Yeah.
as nobody because nobody's running it. And guess what? Edits to this knowledge objects are not logged in the audit.
Yes.
What was actually changed?
Yes. Go to ideas.splunk.com and find that idea and vote for it because God, we need that.
I already have that. The auditing of what was changed. Yeah. So if somebody wants to see what that search looks like to check that, I can post that to the Splunk user group, the Boston channel.
I'd like to see it.
That idea 49, huh? It's been around for a while. I can't get to it from this browser because something's blocked. Oh well. Yeah. All right. Well, anybody else have any other interesting things?
Hi, this is Abhishek. I have one question. So regarding the Splunk Cloud, when you want to do the security orchestration using Phantom, and generally when the data, if you are having a Splunk Cloud and you deploying the Phantom, so when you're doing the automation, generally you wanted to run suppose ping or you wanted to shut down the server, those are on-prem. So whether the Phantom fits in that architecture, where is going to be on the cloud, or is just like Splunk Cloud will be sending the data into the containers to the on-premise Splunk Phantom, and we will be using the Phantom, which is available on-prem, to do all this automation. So I was just wondering, like, what the architecture should like be.
Does anybody know more about this than me? I can speak to it, but I'm a little bit ignorant. I believe the current state is that you're going to be running Phantom on-prem, and the Cloud Splunk will be sending notifications out to that. We do have, this is a forward-looking statement, but I think we've announced it. We have a cloud version of Phantom coming, and for that, you will still have an on-prem piece that will handle those kinds of actions that have to happen inside your network, and there's a communication bus between the two, so that you can sort of manage all the Phantom stuff on the cloud side, but you have this stub on your end that handles the actions.
Okay, thank you.
Anybody else? And yes, that idea on Splunk ideas, yeah, that's the one I'm watching that voted for, and then the whole discussion of how this app is gonna do what you want, and everybody saying no, that's not gonna do what you want. No, that was kind of fun to watch.
I've enjoyed the Ideas platform for this reason. It really gets some of those conversations that sort of used to be very internal out into the open, and it's helping our PM folks a lot.
Yeah. Well, I mean, as long as we're talking about it, the most important idea for those who watched the what was it with the Will Ferrell at Conf, then you want to take a look at this idea, because obviously that's what we need to do. But if there's no other questions, then we can wrap it up here. Thank you, Russ, for pulling this together. This was very informative. And
yeah, thanks for the opportunity. I'll post a PDF in the Boston channel and follow up with a couple of these questions as well later on in the week, or maybe early next week.
Awesome. And then, yes, we are planning to have in May, let me just check the names. Yeah, a couple of people coming in, or one of two people coming in Clara Merman or Merriman or Mason Ralphs to come and talk about how Splunk monitors and does Splunk internally. So I'll be good. See you then.
Thanks, everyone.
Bye.
Great job. Thanks, everybody.
Thank you, everyone.